So this kind of question usually starts off by giving you a list where you need to do matching or fill in the blanks where you can use them more than once or not at all. Alright, so which compound is a gas? Gas, so that's the first information, dissolve in water to give you alkaline solution. So looking at these aluminium sulfate, how you can see is Al3 plus and SO4 2 minus. The fact that you have a 3 plus and a 2 minus, so something which I did in lower secondary, well sorry not lower secondary, primary school, is to do with lowest common multiple, LCM. So the LCM is equal to 6, so meaning to say we are trying to balance the charge to get it up to 6, so that is why I need 2 of the Al3 plus to bring it up to 6, and this is 2 minus to bring it up to 6, I need 3 of it, and which is why the formula is Al2 SO4 3 times for aluminium sulfate. Different schools or different teachers will have taught it differently. You might be doing the crisscross cross multiply method where the 3 plus and the 2 minus they exchange place and you get 2 and 3, but essentially they all come down to the idea of balance the charge to give you a formula of this ionic compound where the ions are balanced out in terms of charges. Ammonia is NH3, calcium carbonate is Ca2 plus CO3 2 minus, meaning to say the formula again, if you think about the LCM is going to be 2, therefore just need 1 unit of this and another unit of that. Carbon dioxide is CO2, chlorofluorocarbon is just CFCs. They are organic compounds that contain carbon, that contain chlorine and fluorine, but we don't know just from the name itself how many chlorine or how many fluorine, so I'll just write it down as CFC, which is just an abbreviation for that particular family of compounds. Copper 2 plus means you have copper 2, which is copper 2 plus, then you have SO4 2 minus, giving you CuSO4, one of the major case study when you come to electrolysis of aqueous copper sulfate, both using the copper electrode as well as using the inert electrode, which is graphite electrode. Then you have hydrogen chloride, which is HCl gas at room temperature and pressure. But this HCl gas, which is a pure substance, it can dissolve in water to give you hydrochloric acid, which is a mixture. HCl gas dissolve in water. 2 different compounds give you a mixture because they are simply mixed together. Potassium nitrate, K plus NO3 minus, KNO3, and sodium chloride, Na plus Cl minus, give you NaCl. So your table salt there. Right, so which compound is a gas which dissolves in water to form an alkaline solution? That has got to be the ammonia. Ammonia, as we know, is highly soluble in water and the one you use for qualitative analysis, whether you are doing practical as well as in theory paper, because it's also in your theory syllabus. For O-level chemistry, they can ask you the test with ammonia, with the various cations, whether you're in paper 1, 2, or even alternative to practical. Especially if you don't have exposure to doing practicals, those might be the theory papers when they can test you on the kind of thing where you'll be expected to have a table in paper 3, but you don't have such a table in your theory paper at all, so you really need to know them. Next one is an anhydride solid used to test for water. Test for water. Anhydrous means no water of crystallization. Okay, so this is part of the syllabus under hydrated versus anhydrous compounds. Basically the compounds that there's anhydrous that has no water crystallization. The test for water will be the copper 2 sulfate there. Alright, okay, so when it's hydrated, it becomes blue in color. Contain ions with a 3 plus charge. By going through these, I hope you can see that this is the one that has the Al3 plus, so it's the only one that has 3 plus cation, so it's aluminium sulfate. The next one is to do with flue gas desulphurization. So this is part of your nitrogen sulfur chemistry. So some power plants might give off some sulfur dioxide and you want to get rid of the sulfur dioxide, so what you do is you will react it with calcium carbonate. So this is an acidic oxide. When you have an acid reacting with a carbonate, what you can get is you can get a salt, which is calcium sulfite, and in this regards you also get CO2, but you don't get H2O because there's no hydrogen here, but you obviously get CO2 because it's a carbonate plus an acid experiment, but no water because no hydrogen here to begin with. This is not a redox reaction, this is an acid-base reaction. So this is acting like a base, this is the salt. Okay, but of course it's not a simple neutralization, it's actually behaving like acid carbonate kind of reaction. All right, so calcium sulfite is a SO3 2 minus, and it is different from sulfate, which is ATE, which is SO4 2 minus. These are common things which you would have done when you did formula of ions back in, I don't know, whichever year you are in, when you did this O-level syllabus thing. Yeah, eutrophication is a result of the washing away of the excessive use of fertilizer which contain nitrates into the river water. Okay, so we're looking for something that has nitrate, so potassium nitrate is one of them. So nitrates are extremely soluble in water, so when you have fertilizers that contain a lot of nitrates, when rain comes, especially when it's heavy rain, the nitrate fertilizers or something that contain nitrate can dissolve in the rainwater. When they get washed down to a river, they can cause accumulation of nitrate in the river water and causes an excessive growth of your algae or algae plant, and they will essentially cover the top of the river surface, preventing sunlight from reaching the rest of the aquatic plants. Therefore, the aquatic plants cannot photosynthesize, your aquatic plants will die, and since your aquatic plants are the one that photosynthesize and give you oxygen, so not enough oxygen in the water for other animals to live, therefore your animals will die, therefore the whole ecosystem will collapse. Okay, so that is eutrophication being summarized for you there.